All right, so yesterday we learned a bunch about the greatest common factor, aka the GCF. So greatest common factor. Now when you break that down, greatest means biggest, common means that something that two or more things share, and then a factor, so a number that could be divided into other numbers. So let's take a look at number 1, and our goal here is to factor out what our greatest common factor is. So the first step is we need to take a look at all of our numbers. So we have 2, 2, and 8. So what that automatically means is that I have a greatest common factor of 2 to 8. That means everything is divisible by 2. And now when I take a look at the variables, they do not all share an x. So my greatest common factor here is just 2. So what this means is I need to factor out a 2. And when I factor out a 2, I could show it by dividing everything by 2 to see what is left over. So 2 divided by 2 is x squared. 2 divided by 2 is 1x, negative 1x, plus 8 divided by 4 is 2. And notice this becomes my factored form. And so our goal is to factor out our GCF so we can factor all these, or put all of these from standard form into factored form. So taking a look at number 2, we have 6x squared plus 3x minus 15. So 6, 3, and 15, that would mean the GCF is 3, because the greatest number that they are all divisible by is 3. So I'm going to start by factoring out my 3. So if I factor out a 3 here, 6 divided by 3 is 2x squared. 3 divided by 3 is 1x. Negative 15 divided by 3 is minus 5. And so here's my factored form. Now, if you wanted to check your work, if I wanted to check my work, what I would do is I would take what I had and distribute to see if that's what I should have. So 3 times 2 is 6x squared plus 3x. 3 times negative 5 is minus 15. And notice when I check, I'm correct, right? Because the inverse operation of factoring is multiplying, right? So now moving to number 3. So we have negative 3t squared plus t. So notice I said t squared plus t. Right off the bat, I know that my GCF is automatically t because they both share a variable. Now yesterday we learned that if your leading coefficient, which is your first number, is negative, you will factor out a negative number. Okay? So my GCF is a minus t. Okay? So when I factor out a negative and a negative here, negative 3 divided by a negative symbol is just 3. Now if I have 2 t's and I factor out 1 t, I'm left with t. Okay? Now we have a positive divided by a negative means minus. If I factor out a t, I'm left with a 1. Right? Because technically this is 1 divided by 1. And so here is my factored form. In a problem like this would be good to check. A lot of students like to put 0 here, which anytime you multiply by 0 is 0. There's no zeros in your problem. All right, number 4, negative 5y squared minus 10y. So right off the bat, we know our GCF is a negative. What number could you divide 5 and 10 by? Well, 1 and 5. So the GCF here is 5. And then when I take a look at my variables, I have 2 y's here, and then I have 1 y there. So they have 1 y in common. So now let's factor out our GCF of negative 5y. So I need to divide by negative 5y and negative 5y. So this will give me a positive 1y. And then negative 10 divided by negative 5 is a positive 2. I already factor out a y. So I could show the y here and show how they cancel out. to see what I'm left with. Okay, so I'll show it in another way. So, other way to do it. So if I have negative 5y squared minus 10y, and I divide by a negative 5y, because a negative 5y is my GCF, okay, that gives you 1. And then y squared divided by y, well, that cancels out one of the y's. Negative 10 divided by 5 is a positive 2. And then a y divided by y cancels. So that's another way of showing it, is by putting the variable and canceling out. So if I went back to number 3 as well, if I put a t there, right? That's how I'm left with just a t. That's how I'm left with minus 1. All right, number 5. Nice long problem for you. So number 5, if we take a look at it, it has 4 terms. So we need to find the GCF of all of them. All right, so the first question is there a GCF? So let's take a look at our numbers. We have 6, 12, 24, 30. And so yes, the GCF here, you could divide them all by 6. That is the greatest common factor. Now let's take a look. We have 8 x's, 6 x's, 4 x's, and 2 x's. So the common factor is 2 x's, right? So what this means is I am going to divide each term by 6x squared. Okay? So when I factor out a 6x squared, let's find out what's left over. So 6 divided by 6 is 1. And now, how many x's am I left with? Well, if I had 8 on top and 2 on bottom, I'm left with 6. 12 divided by 6 is a positive 2. I had 6 x's on top and 2 on bottom, which means I'm left with 4. Negative 24 divided by 6 is negative 4. I had 4 on top, 2 on bottom, so I'm left with 2. And then 30 divided by 6 is 5. I am not left with any x's, so I am done. Okay, so go ahead and copy down number 6. I'm going to pause the video, and then I will share the answer with you. So go ahead and try it. So check your answer. So you should have gotten negative 1y times 6y squared minus 9y plus 4. All right, so let's take a look at the second topic. So the second topic we're going to talk about today is what we call factor by grouping. Okay, so factor by grouping. So just like factoring out a greatest common factor, one can factor out an entire factor if it is common. So when you call something a factor, it means something in parentheses like x plus 7. That's a factor. Okay, so this is what I mean when I say factor. Okay. So if we take a look at example 1, we have n times n minus 6 plus 3 times n minus 6. So we want to factor by grouping. And so right away, I see that the common factor is n minus 6. So our GCF is n minus 6. So what I'm going to do is I am going to factor out the n minus 6 first. So when you factor it out, you then have your second parentheses. So what happens when I factor out an n minus 6 here? Well, it's gone and I'm left with n. And then when I factor out an n minus 6 here, I'm left with just a plus 3. And so this is called factored form as well. The quantity of n minus 6 times n plus 3, which you've seen this before, right? You've seen two binomials being multiplied. Okay, let's go over to number 2. So x squared times x minus 9 minus x minus 9. And so right off the bat, our GCF is x minus 9. It is what is in common, right? It's the greatest common factor. So I factor out the x minus 9 out of both terms. And so when I do that, I need to put whatever is left over. So when I factor out an x squared, x minus 9, and I divide it by x minus 9, I'm I'm left with just x squared. And then x minus 9 over x minus 9 cancel, and I'm left with a minus. Well, what happens when you divide the same term by the same term? Gives you a 1, right? Because 4 divided by 4 is 1, 9 divided by 9 is 1, right? So the same factor divided by itself is 1. And there we go. All right, so number 1, factor by grouping. So here's some examples, and I'm going to keep example 1 and 2 up because you're going to see how it connects. So what you do for factor by grouping. Step number 1 is group 2 terms together. So what this means is I need to group the first 2 terms together and the last 2 terms together. Step 2, find the GCF of each group. Okay, so when I take a look at group 1, what is the GCF between x to the third and x to the second? Well, it is x to the second. Okay, so what I'm going to do is I'm going to factor out x to the second and find out what I'm left with. Okay, so x to the third divided by x to the second is just x. And then 2x squared divided by x squared is left with just 2 because they cancel out. Right, and so 3 of them cancels with the 2 down here. Cool. Now next group, I need to factor out the GCF. So plus 5x plus 10, the GCF is a positive 5. Okay, so I need to factor out a plus 5. You have to show what the symbol is. So when I divide each term by a plus 5, 5x divided by 5 is just 1x. And then 10 divided by 5 is 2. Okay. Step 3, are there more GCFs? So if I take a look at what I have, do I have more greatest common factors? And the answer is yes. X plus 2 is my common factor. So what this means is I need to factor out an x plus 2. I need to factor out an x plus 2 here. Okay, so let's see what that looks like. And again, that's what we did in example 1 and example 2. We factored those out. So I'll zoom out so you can see it. Right, so if I factor out an x plus 2, I'm left with x squared plus 5, right? Because they cancel, and that's what's left with. Okay, this video will be continued into a second video.